All right, calcification is our next big topic for the day. This is calcification, mineralization, whatever you want to call it. I'm fine with those two being used synonymously. I am not okay with calcification and ossification being used the same, because they are not the same. Calc is calcium. We're calciumifying. Os is bone. It means you're bonifying. Those are different things. Bone is a living tissue composed of things, one of which is calcium, but there are many other things. So ossification and calcification are not the same thing. Calcification, mineralization, sure, fine, same, whatever. This is a result of disruptions in calcium metabolism, either at the local or the systemic level. What this looks like in tissues for you guys, calcium is going to be hard. So remember, soft as your lip, firm as your nose, hard. Firm as your nose, hard is your forehead. Calcified tissue is hard. It's bony. It's gritty. It's bright, screaming white. It's a weird white. It's like bright, like new t-shirt white. Here are the major causes of pathologic calcification in tissues. Again, there's two major and two minor. I really want you guys to focus on these major ones. Remember, iatrogenic means you did it. Oops, you gave too much vitamin D, too much calcium, but the calcium excess. Do we know idiopathic yet? No. What does it sound like? What's the root word in there? Idiot. Idiopathic means we have no idea what the cause is. We are idiots. We don't know. Sorry. Okay. So dystrophic calcification is the first type. This is a local disruption in calcium homeostasis, and it happens when cells are dying in an area. So a cell dies, it loses control of its ATP. After it has no ATP, it loses control of its calcium metabolism. The cell is falling apart because it's dying. Calcium is now going out into the interstitial space and just depositing. So dystrophic calcification happens where tissue is dying. And the importance of it is that it tells you that there was tissue death here. If I see a localized area of mineral, it tells me that there is death going on in the tissue, and that's important, potentially diagnostic information. You're most likely to see this, or you see it most severely in tissues with high levels of calcium storage innately. So muscle is the big one. Muscle is very likely to minimize necrosis. We all heard of white muscle disease. That's calcium. White muscle disease is necrosis of muscle cells. They lose the ability to regulate calcium. They spill calcium out. The heart tissue or the muscle tissue becomes pretty white because it's dead, and then it's mineralized. So that's dystrophic. Very, very importantly, systemic body-wide calcium levels and metabolism are normal in these animals. This is just a localized disturbance because people are dying. Our whole body calcium stuff is okay. We're good. Unless we die from whatever is causing the tissue necrosis. Yeah.
Localized like a foot, like organ localized, or localized like my hand localized? Like the muscles in my hands are dying, so they're gonna be calcified.
So it could be either. I would consider both of those localized, right? Like if you have, I don't know, diabetes and you get gangrene of the distal extremity, or you actually took me literally when I said to cut off the blood supply in your hand the other day, right? Your tissue would die. There would be calcification. That's localized. Your systemic calcium is normal. I'm assuming in this scenario, that's dystrophic. White muscle disease, vitamin D selenium. It's like I knew this was coming. I actually forgot. So here we have a heart, and this is a cross section of tongue. We also take tongue in large animals to look at the muscle. So all of this white stuff, see how bright white that is? It's like a weird white. And also if you touch this, it would be hard, it would be gritty or kind of chalky. It would feel like mineral. Same on the tongue. There are all these little white areas. Sometimes they're kind of streaky in muscle. Here it is on the endocardial surface, and it's actually going into the myocardium. So all of this white is dead muscle. Dystrophic calcification. The cell death came first, and then the calcium. Cannot blame calcium for this, it's an innocent bystander, had nothing to do with this. Hammering it home, secondary to necrosis, serum calcium is normal. There's little foci of calcium, this is probably migrating parasite tracts or little granulomas. Here's what that looks like on histo. Mineral is very blue, it's like this blue extracellular lake. All right, done with dystrophic. Metastatic sounds like metastasis, right, where things spread all over. So this is a whole body systemic disruption in calcium metabolism. Calcium precipitates in tissue because you have too much calcium everywhere. And the calcium causes tissue damage. So it's like the opposite of dystrophic, right? Dystrophic, the damage came first and the calcium is just a bystander. Here the calcium came first and it is causing death of tissue. Tissue is otherwise normal and healthy before the calcium got there. This is calcium's fault. That's not, this is. Calcium did this. Calcium is the etiology. Major causes in vet med, so there is a lovely acronym because we all love those. So hard ions, G is the acronym I learned. So these are causes of hypercalcemia. So metastatic calcification is associated with these diseases because we have full body elevations of calcium. The most common causes we see in vet med is chronic renal disease and failure, vitamin D toxicity, hyperparathyroidism. We also see some paraneoplastic syndromes that mimic hyperparathyroidism. We're going to learn all about those. And destruction of bone. So you're destroying bone, you're releasing calcium in blood. All right, metastatic calcification is death by calcium. Any organ is susceptible to this. These are kind of the common areas that I see them. So again, tissues with high calcium metabolism are going to be affected. Your muscles, the intestines, the gastric submucosa will mineralize frequently. We see that with renal disease, the interstitium of the lungs, the kidney, and the blood vessels. So death by calcium. Calcium is causing this. Calcium is calcium. It looks the same in tissues. You're going to use the distribution and the signalment and history of the animal to help you decide if this is metastatic or dystrophic, right? So does the animal have some kind of primary thing that could be causing hypercalcemia? Does it have real bad renal disease? Did it, eat a bunch of rat poison? Hypercalcemia is causing mineralization of tissues. These are all common sites of mineralization we see in renal failure. So again, this is a stomach. We're looking at the wall of the stomach. So here it would be like the lumen. This is the mucosal surface. This is the serosa. And all of this white, gritty little spots in here is all mineral. Here we are in the kidney. All the streaks are mineral. So linear streaks in the cortex. And also here, the corticomedullary junction. This is the pleural surface of the rib cage. So we take the ribs off when we're doing a necropsy and we look it down, lay it down, and we look at the intercostal spaces. So these are the muscles. Intercostal muscles are mineralizing. All this bright white, gritty stuff. Here's another gastric submucosa. You can actually see little nodules of mineral. All right. Questions on dystrophic versus metastatic? Yeah.
Is there with dystrophic any disposition, like if they were to further injure themselves, like in a car accident or something, that this would happen again?
Death is death. Yeah, cell death is cell death.
So is there like a genetic predisposition to this, or it's just
To dystrophic?
any?
Yeah, no, anytime there's tissue damage, there can be mineralization.
Does where the calcification occurs, how far away from the answer my question.
Dystrophic always happen in dead animals, or does it mean like some?
So it's not a dead animal, it's dying tissue.
Okay.
Dying tissue while the animal is alive. So the tissue is able to respond to it. So there will be like inflammation, there will be other things associated with it that'll tell you that, oh, there's been damage here. It's not just mineral. Great questions. We gotta keep going, or we're not gonna make it, guys. That's me and Dr. G when she was a resident, doing a shark. Okay, gout. We do have some gout for you upstairs today. This is deposition of urates, so urate crystals. You only see this disease in certain species that lack the enzyme that breaks urea down. So urease. Humans, non-human primates, reptiles, birds, those are your gout species. Other species not susceptible to gout unless they have some weird genetic mutation in their urease. This is the result of chronically elevated uric acid in the serum. So causes of elevated serum uric acid, this is a waste product, so you have renal disease, you're not able to excrete uric acid. You're dehydrated and you have an increased concentration of uric acid in the blood because you have less water, or you have a high protein diet, so you're consuming more things that are being broken down into urates. There are two forms, it can be visceral or articular, or both. So it can deposit on the surface of organs or in the joints. Here we're looking at a bird pericardium, so the heart is in here, but you can't see it because it's covered by pericardium. You can barely see the pericardium because it's all white and gritty. So gout looks very similar to mineral in tissue. It's kind of this white, gritty, it forms kind of plaques on surface. So that's the difference between gout and mineral. Mineral is often inside of tissues. Gout is often kind of like on the surface of tissues because it's kind of precipitating. You can get it deposited like in your kidney. So that's the area where it does actually go into the parenchyma. All right, exogenous pigments. Remember, exogenous is coming from outside. So these are often non-biologic, some plants, tattoos, certain drugs cause pigments that deposit. There are some infectious agents that produce like melanin analogs for radical scavenging. So you can have bug pigments, blood pigments. This horse was obviously a smoker or worked in a coal mine. He's got little black dots in his lung. That's probably carbon, silica. And then endogenous pigments. So endo, inside, these are pigments that you are making that can deposit or accumulate. So melanin, lipofuscin, blood pigments. We're going to spend a lot of time talking about blood pigments. By a lot of time, I mean 12 minutes or less. All right, melanosis, a condition of melanin. So melanin is produced by your melanocytes. This causes an incidental dark black discoloration of tissues. It has no functional significance. Your job is to just see this, make a note, and move on. I see this, I recognize that it is maybe not normal if I'm playing spot the difference between this open piglet right here and a normal open piglet. Most piglets don't have a bunch of black dots inside. However, this is not pathologic, didn't cause the death of this animal, not even related to the death of this animal, has no functional significance in tissue. So I'm gonna note it, I'm gonna note it's there. I'm gonna wanna differentiate this from things like metastatic melanoma, right? This could be a metastatic disease. We have little black dots in the lung and liver. That could be a metastasis of a neoplasm. It could be hemorrhage. Sometimes hemorrhage looks really dark black. So these things, we want to distinguish them from disease, but they're not disease. Here's melanosis in the meninges. Also in the meninges, this is a silky chicken. Even their bones are black, which is pretty cool. This is, you can't really see it very well, but this is the skull, the bones of the skull, and it's dark black. Here's a larynx and some kind of ruminant. Lipofuscin is the wear and tear pigment. So we see these in cells that are very long lived. We see it more in older animals. This is just the end result of autophagy, self-phagy eating, autophagy. So this is how we recycle damaged organelles. We break them down in their components and then we reuse the components. There are some things that are like indigestible and product like cellular poop, I guess. But cells can't poop, so they have to just kind of like hold on to it. So every cell has a little closet where they store their poop. And once the cell is old enough or the animal is old enough, we can see their closet full of poop under the microscope. See, even kind of looks like poop. So this is a very old cell. It has not pooped in a long time. Stop saying that. I'm not stuck in a loop, a poop loop. You're usually not gonna see it grossly. It's usually just under the microscope. If it's hella severe, which it never is, it might cause a little bit of like brownish discoloration, so right here in the brain, brown, blood perfusion. There's another one that's inert, it's harmless, we're just gonna note it and move on. All right, so the last big thing we need to talk about, blood pigments. So these are the breakdown products of hemoglobin. I have listed the major ones for you. We're going to talk about as many as we can get through in 10 minutes. Have we learned this yet? Pathway of red cell metabolism. Yeah. In phys or elsewhere? No, cool. Here it is. Learn it real fast.
Okay.
Love that attitude. Thank you. All right, so we're going to talk about icterus. Icterus is the accumulation of excess bilirubin in the blood. Icterus and jaundice are synonyms. So these are both referring to a yellow discoloration of tissues. There are 3 and only 3 mechanisms of jaundice or icterus. And it's based on this pathway. So the liver is the site of metabolism. The kidney is the site of excretion. The red blood cells are the site of production, right? So if we think about places we could stop this pathway to build up bilirubin, we could have too much blood breakdown coming in. So there's too much coming into the liver and the liver can't handle it. We have liver disease and the liver is unable to process the incoming bilirubin. Or we have normal amounts, we've processed it okay, but we have some kind of obstruction in usually our biliary tract, so like gallstones could cause this, and we can't get rid of it, so it's building up. So those are the 3 mechanisms. It's prehepatic, there's too much coming in and the liver can't handle it. It's hepatic, the liver is diseased and can't handle even a normal amount of bilirubin coming in, or it's posthepatic. There's normal amounts coming in, we process it appropriately, but we have an obstruction in our bile tract and we can't get rid of it. Prehepatic, so too much incoming bilirubin, liver can't deal. Liver is normal. 2 major causes of this: internal hemorrhage, so we're bleeding inside and those blood cells break down and we're reabsorbing them because we need the iron, we need the protein, we need all that stuff. So we've got a lot of broken down red cells that we have to process real quick. Hemolysis is kind of a similar situation. So these are both instances where you have red cells being broken down inside the body at a very high rate, and it clogs the liver. Liver can't heal. Because the function of the liver is to conjugate bilirubin and make it water soluble, so it can be excreted into the urine. We're stuck up here, we're not able to conjugate. So you will have mostly unconjugated bilirubin in the blood. And you will have no elevation in urine bilirubin because it's not making it there. This is prehepatic icterus. Liver's fine, but it's like Black Friday at the liver for bilirubin metabolism. Liver cannot handle this. It's going to build up. All of this bilirubin is just going to hang out in the blood waiting for the liver to deal with it. You're turning yellow. Hepatic icterus. I have severe liver disease. The liver is not able to process bilirubin even when it's coming in normal amounts. Clinically, you will have a mix of conjugated and unconjugated depending on how severely your liver is damaged. Maybe it can still conjugate a little bit of bilirubin, maybe it can't conjugate any because it's toast. So it's a mix. Urine bilirubin may or may not be elevated, depends on how much conjugation you're doing. So if your liver disease is very acute and severe, your liver is trashed and you're conjugating no bilirubin, it's going to look more like this on your labs. And it's going to be mostly unconjugated bilirubin and no urine bilirubin. Depends. This is hepatic icterus. We have a normal amount of bilirubin coming in, but the processing plant is on fire. We will not be conjugating bilirubin here today. Please come back tomorrow, or maybe a couple days. Over here, there might still be liver cells in here hard at work conjugating bilirubin, right? In the part of the building that's only smoking and not on fire, because that's how your liver goes to work for you. It's like, nope, still gotta make bilirubin. Building's on fire up there. I don't care, I've got a job to do. That's your liver. It's gonna keep going until it can't. So we're gonna conjugate a little bit as much as we can. But we're also not doing a great job, and this fire is probably gonna spread. Eventually, these guys are gonna have to leave. Get the stairway to heaven. Post-hepatic icterus, we're making normal amounts, we're processing it appropriately. We have a bile duct obstruction or a gallbladder obstruction. We've conjugated it all, we're finished with it. So this is all conjugated bilirubin in blood. And we're gonna see a lot of bilirubin in the urine, because it's all water soluble, it can get there. This is post-hepatic icterus. We've had a great time at the liver, now we're trying to leave. It is not gonna happen, we're stuck. By definition, icterus, jaundice, this presentation means you have too much bilirubin in the blood. Hyper, too much bilirubin, self-parent, anemia of the blood. Urea of the urine, so hyperbilirubinuria versus hyperbilirubinemia. That makes sense? Is there anything I need to talk about that you can't just read on your own for the rest of this? I think that pretty much covers it. I want your questions about the big stuff.
Would you ever see a decrease in the urine concentration or something?
How much urine bilirubin is normal, please?
One.
If you're like a male dog. Very low amounts of bilirubin normally, more commonly in mammals, more common in some species. So there isn't really less than none.
Okay.
Usually it's none. Very low. Questions? Overlap it. Oh,
My question was just, we see a lot of deposition, like we're going over the salts and stuff. Like most of them are like the liver, or the kidney, or dealio with deposition, so I need to go with kidney for the liver.
so remember that deposition usually occurs at the site of production or elimination, and your liver and kidney do a lot of both of those things.
Okay.
Elimination and metabolism, your liver does a ton of metabolism, so the liver is frequently involved in these kind of disturbances.